Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Welcome to our first topic in mathematics of finance is going to be interest. Interest is the amount that has to be paid by the borrower to the lender because of the using of capital. There are two types of interest, simple interest and compound interest. Simple interest is the interest that is calculated based on the principal. It means that only the principal earns interest. The amount of the simple interest due at the end of the term depends on the principal, the length of the term, and the rate of interest. So before we do that, let's go over some basic concept here. Alright, P stands for principal. Principal is the initial amount of money that you will invest. Then I, that's called interest. You will earn interest, and so the units for interest is ringgit. A stands for accumulated amount. The total amount that you end up with will be the initial principal you put in the bank plus whatever interest you earn on top of that. Next, R is called for rate. That's called the interest rate, usually expressed in percent or in demical. So that's how fast you will be accumulating interest is based upon the rate and of course about how much you invest as well. Finally, T, the time, and usually it's expressed in years. How long will you put your investment in the bank? So the formula principal times rate times time will give you interest earned. The result is in ringgit. Okay, next accumulated amount is the amount that you end up with at the end. And since the interest that we earn is going to be equal to PRT from our definition, we can then factor out P the principal. So that means the accumulated amount will be the principal bracket, it is times 1 plus the rate times the time. Alright, so here's an example here. Let's say that we are going to invest 2,000 ringgit at 5% interest rate and we do it for 3 years, but it's simple interest, which means that the interest you will earn interest equal to the principal times the rate times the time, which is going to be equal to 2,000 ringgit times the rate, which is 5%. So that will be 0.05 times the time, which is 3 years, and then so that you will earn 300 ringgit after 3 years, and then you will get your 2,000 ringgit back. So what would be the accumulated amount? So since the accumulated amount is equal to the principal plus interest, so in this case, the principal will be 2,000 ringgit. That's the initial investment plus the 300 ringgit that you earn and interest after 3 years, which is equal to 2,300 ringgit, which will be the accumulated amount that you will end up with after 3 years. Okay, now we go to the basic concept of what compounded interest is and the comparison between simple versus compound interest. Alright, compound interest can be calculated by yearly, semi-annually, it is a half a year, monthly, daily, and hourly. So, we are going to start with compounded yearly. That means every year we are going to add the interest earned to the principal, and that will now become your new principal. So we get 300 ringgit for the simple interest, right? So the formula is A equal P bracket 1 plus R divided by N power of NT, where A is the ending amount, P is the beginning amount or principal, R is the interest rate expressed as a demical, and N is the number of compoundings a year, and T is the total number of years. Okay, so with the same problem, amount will be equal to the 2,000 ringgit invest times 1 plus the rate, which is 0.05 divided by the number of compounded per year. In this case, we are going to do one conversion per year. So n is 1 times t, which is 3 power. So becomes 2000 ringgit times 1 plus 0.05 divided by 1 and power of 3. So this should be equal to 2000 ringgit times 1.157625, and then you will get 2315 ringgit and 25 cents. Okay, next, monthly compounding. If yearly compounding, we will earn 2,315 ringgit and 25 cents. So let's see how much more you would earn if you were to compound monthly. So here n is going to be 12. So accumulated after 3 years is equal to the principal investor, which would be 2,000 ringgit times 1 plus the rate 0.05 divided by the number of conversion. So in this case, monthly would be 12 and then raised up to 12 times t would be then of course 3 years. So we raised that to the 36 power, so equal to 2000 ringgit times 1.16147221. We get a total amount accumulated A to be equal to 2,322 ringgit and 94 cents. Okay, next, compound interest with daily compounding. Here's the equation for compounded interest. The amount earned equals the principal times 1 plus the rate divided by the number of conversion daily, means n is equal to 365 times t. So you can lay that amount would be equal to the 2000 ringgit inverse times 1 plus the rate 5% divided by the number of conversion 365 per years and the power of 365 times 3. So then you have the equally accumulate amount equals 2000 ringgit times 1.161822307. So amount of accumulated would be equal to 2,323 ringgit 64 cents. And lastly, compound interest have two hourly compounding. Just follow the same steps and formula. And lastly, I would like to explain about effective rate of interest. Let's say 100 ringgit invest at 5% for 1 year. So the question is A compounded monthly, B compounded daily. So follow the formula. Effective rate of interest equal bracket 1 plus effective 1 plus rate divided by n is number of compound a year, power of n minus 1. So we are going to do A first. In the case n equal 12 because there's 12 months in a year. So effective rate equal 1 plus 0.05 divided by 12, power of 12 and minus 1. So the answer is 0.05116, and conversely to the percent it is 5.116%. So this is called the effective rate of interest when we compound monthly at 5%. So what would be if we compound daily for the B question? Okay, effective rate equal 1 plus 0.05 divided by 365 and raise up 365 minus 1. So we get 0.051267. That's mean going to 5.127% because rounded out to 3 decimal places. To notice, the effective rate of interest if we compound daily is a little bit higher than the effective rate of interest when the compound monthly. So that's what we mean by the effective rate of interest compounded monthly at 5% is 5.116%, and compounded daily is 5.127%. So that's all for interest in mathematics of finance.
Hi and Assalamualaikum warahmatullahi wabarakatuh. Name Hanan Sofia binti Muhammad Syarizal. Matriculation number 1210809. Present value PV is the current value of future sum of money or stream of cash flows given a specific rate of return. Future cash flows are discounted at a discount rate. The higher the discount rate, the lower the present value of the future cash flows. Formula of present value: FV divide by 1 plus R to the power of n, which is FV future value, R rate of return, and number of periods. The present value tells you how much you had need in today's ringgit to earn a specific amount in the future. Net present value (NPV) is the difference between present value of cash inflows and the present value of cash outflows over a period of time. This is the formula of NPV, which means RT, net cash inflow or outflows during a single period time. I, discount rate of return that could be in alternative investment. T, number of periods of time. If you are unfamiliar with summation nation, here is an easier way to remember the concept of NPV. NPV equal to TVECF minus TVIC, which is TVECF is today's value of the expected cash flows and TVIC is today's value of invested cash. I will skip the question first because it's the future value. So the second question, what is the present value of 100,000 ringgit 10 years from now given the same annual interest rate of 6%? The future value given is RM 100,000. 10 years from now, an annual interest rate of 6%. The formula we have to use is PV equal to FV divided by 1 plus R to the power of n. So, 100,000 divided by 1.06 to the power of 10. We will get PV equal to RM 55,839.48 cents. So, the final answer present value is RM 55,839.48 cents. Company B plan to invest RM 45,000 in Company A in the hope of getting a return RM 50,000. Company A decide to pay them at rate 10% and pay 3 yearly for 1,000 each. Find the net present value. Year 1, 1,000 divided by 1 plus 0.10 will get RM 909.10 cents. Year 2, 1,000 divided by 1 plus 0.10 to the power of 2 will get RM 826.45 cents. Year 3, 1,000 divided by 1 plus 0.10 to the power of 3 will get RM 751.31 cents. Year 4, final payment is 50,000 divided by 0.10 to the power of 3 will get RM 37,565.74 cents. Next. So, sum of present value is RM 40,000, 52.60 cents. Initial investment is RM 45,000 and net present value result is RM negative 4,947.40 cents. Thus, at rate 10% is not the best way to make investment because NPV less than 0. present and future value is valuable in settling on venture choices and used to settle a choice on the amount of cash to contribute. Present value provides a basis for determining the fairness of any future assets or liabilities. For example, having a potentially higher purchase price may not be worth having a possible cash refund reduced to present value.
Assalamualaikum warahmatullahi wabarakatuh. My name is Fatin Farzana binti Muhammad Azhar. My matrix numbers is 1210820. So basically today I would like to present about future value. So let's check it out. Okay, so what is future value? Future value is the worth of a current asset at the future date based on a projected growth rate. So growth rate or interest rate and others. Investor and financial planners emphasize future value because it allows them to anticipate how much an investment made now worth in the future. So basically, future value is the present value at plus the interest or growth rate or dividend times with the times or period. Okay, so this is basically future value. Basically, future value is the current asset for a future date. So that's why we need present value, interest rate, and times to allocate future value. Why we need future value? Because it allows them to anticipate how much an investment made now worth in the future. So basically, we want to know what is our future value if we invest it now. So that's what future values mean. So after we know what is future value, we need to know what is the formula of the future value for a simple interest and compound interest. So for simple interest and compound interest, I think we all already know since my class already told and told about you about the simple interest and compound interest. So I will present about the future value for the simple interest and future value for the compound interest. So for future value for simple interest, it is present value times with 1 plus with RT. What is RT? R is annual interest rate and T is time in years. Okay, so compound interest is future value equals to present value and 1 plus with interest rate per period and n with the power of n is number of compounding. So if you can differentiate simple interest and compound interest, I think it is easier for you to find the future value for these two. So this is the formula for future value. Okay, this is some question that you can try or we can try to understand more about the future value. So when Gopal graduated from college recently, his parents gave him RM 1,650 ringgit and told him to use it wisely. Gopal decided to use the money to start a retirement account. After doing some research about different options, he put the entire amount into a tax-deferred IRA that pays 50% interest, compounded annually. Calculate how much money Gopal will have in his IRA at the end of 10 years, assuming that the interest rate remains the same, that he does not deposit any additional money. So we can conclude this that it is compounded annually, so it is compound interest, and we need to find the future value. So the formula for future value and compounded interest is present value times with 1 plus r with the power of n. So we already know that is future value and present value is RM 1,650 and times with 1 plus the rate is 15%. So we need to change it to the percent to the points. So it is easy to add it with 1. So 0.15. So the power of n, the power of this is N is basically the years of the compound period. So it is 10 years. So we need to put it 10 here. So after calculate it, the FB is, which value is, wait, I use calculator. Okay, so after using calculator, I got, okay, so the future value is RM 6675.17. So this is the answer for the future value for the compounded interest. Okay, so this is the right answer, and I think I got it correct. So next, okay, so for the next topic, I will be focusing on future value for the annuity. If you already learned about annuity, I think it is easier to find it. Okay, annuity and future value is, okay, it is quite similar with the sequence and series because it is a payments. Okay, so this is the same payment and period 0, 1, 2, 3. So basically, it is required to the Sn, which is the sum of the sequence. Can you see the the connection between annuity, future value, and the sequence and series? Yeah. So let's look at the formula for this. So this is the formula of the geometry series, and this is the formula for for the future value for the annuity. Okay, so this is the conclusion of the from this to this. Okay, so this is to the sentence, and this is the what we can conclude that it is future annuity from the series. Okay, so this is the formula that we use for the future value. This is the for the present value, which I will not explain to you, but I will explain for you the future value, which is, I think it is quite same. And this is but I will only explain more about the future value. So Sn is the future value. Okay, we can conclude that future value for annuity is similar to Sn. So R is the regular or periodic payment, or we can say that for a certain year we pay every month RM 200. So this is what we call a regular or periodic payment, which every year, every month we will pay 200. So I is basically the interest rate per compounding period. So we can use this as a interest rate. So I will use J for the interest rate, and the compounding period I will use M to get the interest rate. Okay, so N is basically the annuity payment, the number of annuity payment, which, okay, so N is basically the number of annuity payment. For example, annuity is annual. Annual is basically a year, so we need to translate it into a month. So for example, it is, okay, so for example, we need to pay it for 6 years. So we need to times it by 6 times with 12 months, since 1 year equals to 1 year equals to 12 months. So we need to times it, so we get the full month. Okay, you understand? So this is basically how the formula works. So to find interest rate, we need to interest rate per with compounding period, and to find N, we need to times it to change it to the months period. Okay, so to understand more about the relationship between annuity and future value, and how the formula of geometry sequence series is using in the annuity and future value things, is we need to try this question. So let's try the example 1. First of all, find the amount of an annuity of RM 200 ringgit. 200 ringgit at the end of each month for 5 years if the interest rate is 10%. So first of all, we need to write the formula of future value, or Sn. So R times with 1 plus interest rate with the power of n divided by I. This one is minus 1, and this is the formula for the future value annuity. So from this question, we can conclude the information is R is basically RM 200 ringgit, because this is the annuity, the amount of annuity of RM payable at the end of each month. So every each month, this person will pay RM 200 ringgit. So the second one, we need to find the interest rate. The interest rate per compounding period. So the I is basically the J divided by M, which is J, the 0.1%, which I already changed it to the point, so it is easier, which is M is the monthly. So this is monthly. M is basically the period, amount of period. So this is monthly. So we use 12 months. So M is basically N is basically M times with T. So M, we already have M, which is 12. So T is basically 5 years that we use, which is 5. So N is basically 60. So I is basically, from my calculator, is basically 0.008333, and a lot more of 3. So from this question, we just need to transfer it into the formula. So FB or SN equal to R 200 ringgit times B1 plus interest rate 0.008333 with the power of n 60 minus 1 divided by 0.008333. So after using calculation, you can get the answer. Okay, so this is basically the answer for the question. Okay. So this is diagrammatically is what we can transfer from the question. From the question, we can conclude that every month this person will insert 200 ringgit, 200 ringgit, and to edit the 5 times 12 is basically the month. So we are not going to use this diagram, and we just want to use the formula for easy answer. That's all. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Aisyatu Humaira binti Salihuddin. My magic number is 1210870. I am from class NDB 2023/KMB and from group 5. So today I will present Business Mathematics, Chapter 5, Mathematics of Finance, under topic Annuity. So what is annuity? Annuity is any finite sequence of payments made at fixed periods of time over a given interval. The fixed periods of time that we consider will always be equal lengths of time as the payment periods. The given interval is the term of the annuity, and the payments we consider will always be equal of value. Example, depositing of RM100 in saving account monthly for 3 years. So annuity has two types. First is present value and second is future value. Present value of ordinary annuity and present value of annuity due, and for future value, have future value of ordinary annuity and future value of annuity due. So first is present value of an annuity. So the formula A equal to R multiplied 1 minus 1 plus R to power negative n over R. So A here is for present value and R here is for value of each payment that we will make, and N here is number of periods and R is for interest rates. So we have an example, $800 per quarter for 2.5 years at the rate 6% compounded quarterly. So solution is our R is 800. This is our payment that we make, and R is 0.06 over 4. We get 0.015. Here we need to divide it by 4 because it's compounded quarterly, and our aim is 2.5 multiplied by 4 and we get 10. Here we need to multiply by 4 because it's also compounded quarterly. So put it into the formula and we get 7377.75. This is our final answer. This is present value of an annuity. So that is present value of an annuity due. The formula is A equal to R plus R multiplied 1 minus 1 plus R to the power negative bracket n minus 1 over R. So here we have the example, $750 paid at the beginning of each 4-month period for 10 years at the rate of 5% compounded quarterly. So the solution is our R is 750, this is value, and N is 4, N is 10, multiplied by 4, and we get answer is 40 minus 1, and you get 39, and R is 0.05 divided by 4, and we get 0.0125. So put it into the formula and we will get 23788.89. This is our present value of an annuity due. So next is future value of an annuity. So the formula is S equal to R multiply 1 plus R equal N minus 1 over R. So S here is future value and our R is value of each payment, and R is number of periods, and R is interest rate. Quite same with the present value. So next, we have an example for future value of an annuity. $150 per year for 13 years at the rate of 4% compounded yearly. So the solution is R 150 and N is 13 and R is 0.04. So put it into the formula 150 bracket and bracket again 1 plus 0.04 bracket and power 13 and minus 1 over 0.04, and we get 0.50 multiplied 16.626837, and the final answer for future value of an annuity due is 2494.03. Next is future value of an annuity due. So the formula is S equal to R multiplied 1 plus R to power n plus 1 minus 1 over R and minus R. So example here is $170 every month for 4 years at the rate of 0.9% compounded monthly. So our solution is R is 170 and N is 4 multiplied by 12. Here we need to multiply by 12 because it is compounded monthly, and we get 48 plus 1, and the answer is 49. So our N is 49 and R is 0.009 divided by 12. Also here divided by 12 because it's a compounded monthly, and we get the answer is 0.00075, and put it into the formula and we get 170 multiplied 99.89 to 453 and minus with 170, and we will get 8311.72. So this is the final answer for the future value of an annuity. I think that's all. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name Nur Akida Ilana binti Sadiquddin. Number matric 1210806. Now I want to explain about amortizations of loans. Okay, what is amortization? An amortization is the gradual extension of a loan over a period of time by means of a sequence of regular or equal payments as to principal and interest due at the end of equal intervals of time. Okay, now let's see to the formula. The formula is MP equal to P multiply R over M over 1 minus 1 plus R over M power of negative MT. Okay, MP is stand for monthly payment. Monthly payment is a payment that you have to pay according to a set period of time. Okay, P stand for principal. Principal is the initial amount of money that you will invest. Okay, next R stand for rate. That's called the interest rate, usually expressed in percent or in decimal. That's how fast you will be accumulating interest. It's based upon the rate. If the rate is high, you will get high interest. If the rate is low, you will get low interest. Okay, next, M is stand for number of commissions. Uh, number okay, M is stand for the number of commissions per year. If you compound it once per year, N will be 1. But if you compound it monthly, and it will be 12. Okay, next, T it stands for time, and usually it's expressed in years. How long will you put your investment in the bank? If you put it in for 1 year, you will earn interest for a year. If you put in for 5 years, you will earn interest for 5 years. Okay, let's see. You want to buy a house and you must to have big amount. So you don't have a big amount with you. So what you must to do is you must to make a loan or borrow the big amount from the bank. So example, you want to make a loan $200,000 and you want to amortize or pay off the amount over 30 years at 5%. Okay. Okay, what you want, so you must to find your monthly payment, your total payment, and your total interest. Okay. Okay, the principal is $200,000. The rate is 5%, or and we convert to point, so it's P 0.05. The number of commission is 12. The time is 30 years. Okay. Okay, first we find your monthly payment. Okay, the monthly payment we use the formula from the previous slide. Okay, monthly payment equal to our principal is $200,000. Our R over M, our R is 0.05 over 12 over 1 minus 1 plus R over M. Our R is 0.05 over M is 12. Power of 12, power of MT, our M is 12, our T is 30. So the monthly payment we get $1,073.64. Okay, and then we find your total payment and your total interest. Okay, the total payment equal to monthly payment multiply the number of months. Okay, our monthly payment is $1,073.64 and multiply 360. Okay, how we get 360? 30 years multiply to 12, and then we get 360, and the total payment we get 386,500. $510.40. Okay, next we find your total interest paid. Total interest paid equal to total payment minus to principal. Our total payment is $386,510.40 minus to $200,000. So the total interest paid we get $186,510.40. Okay, next is loan balance after X years. Okay, let's see. You make loan $200,000 with 4% for 30 years, and the monthly payment you must to pay is $954.83, and then you want to sell your house after 5 years, and then what is the loan balance? Okay, for this, if you want to find the loan balance, or we call principal remaining, you must to use this formula. Principal equal to monthly payment, multiply 1 minus 1 plus rate over the number of conversions, power of negative the number of conversions, multiply time minus x years, over rate over the number of conversions. Okay, the monthly payment is $954.83. The rate is 4%, and we convert to point, it's be 0.04. The number of conversions is 12. The time is 30 years, and the x is 5 years. Okay, now okay, the principal remaining is equal to $954.83 multiplied to 1 minus 1 plus 0.04 over 12, power of negative 12 multiplied 30 minus 5 equal 30 minus 5 over to 0.04 over 12, and we get the principal remaining on loan balance is 180,894.91. Okay, and let me see the example question. Okay, the question is, a person amortized a loan of $170,000 for a new home by obtaining a 20-year mortgage at the rate of 7.5% compounded monthly. Okay, first, okay. Okay, the question give the principal is $170,000. The rate is 7.5%, and we convert to point, it's 0.075. The number of conversions is 12. The time is 20 years. Okay, now let me find A. A is the monthly payment. Okay, what the monthly payment? Okay, monthly payment equal to principal. Our principal is $170,000. Multiply R over M. R is 0.075 over M. Our M is 12 over 1 minus 1 plus R over M. Our R is 0.075 over M. Our M is 12. Power of negative MT. Our M is 12, T is 20, and the monthly payment we get 100 $1,369.51. Okay, Next, B, we want to find the total interest charge. Okay, the total interest charge. Before we find the total interest charge, we must to find the total payment first. Okay, the total payments is equal to monthly payment multiplied to the number of months, 1,369, $69.41 multiplied to 240 equal to $328,682.40. Okay, and then we find the total interest charge, the total payment minus to principal. Our total payment is $328,682.40 minus to $170,000, and we get the total interest charge is $158,682.40. And then we move to the next question. We want to find the principal remaining for 5 years. Okay, and principal remaining, we use this formula, and then we equal to monthly payment 1,369.51 multiply to 1 minus 1 plus 0.075 over 12 power of negative 12 multiply 20 minus 5 over 0.075 over 12, and we get the principal of remaining, or we also can call the loan balance is $147,733.74. Okay, now we go to accelerated payments. Okay, accelerated payments occur when we want to pay the loans at the shortest time of periods. Okay, let's see the example question number 1. Same borrow 100,000. Same borrows $10,000 at 4.8% compounded monthly. He decided to make a monthly payment of $250. How long will it take him to pay off the loan? Okay, so for this question, we use this formula. T equal to 1 over M multiply IN. We can call IN as a natural log. 1 minus P multiply R over M over MP over IN multiply IN 1 over 1 plus R over M. Okay, the given is P. Our P is $10,000, and our R is 4.8%, and we convert to point, it's be 0.048, and our monthly payment is $250. Our M is 12, and our T is we don't know. Okay, how to find the T is time. Okay, the time, okay, we use the this formula, and we convert the number into the formula, and it's be 1 over 12 multiply natural log 1 minus 10,000 multiply 0.048 over 12 over 250 over to log natural log 1 over 1 plus 0.048 over 12, and we get 1 over 12 multiply to negative 0.17435333871 over to negative 3.99202127 multiply 10 power of negative 3, and we get T is 3.6. Okay, the question is how long will it take him to pay off the loan? So, so the time is 3.6 years. Therefore, he will require 3 years and 8 months to pay off the loan. Okay, and next we see the another example. Okay, Muhammad Smith. Muhammad Smith recently purchased a computer for $1,500 and agreed to pay it off by making monthly payments of $75. If the store charges interest at the annual rate of 12% compounded monthly, how many months will it take to pay off the debt? Okay. Okay, for this question, we use the same formula, and let me see. Our principal is $1,500. Our rate 12%, and we convert to point is be 0.12, 0.12. The monthly payment is $75. The number of conversion is 12, because annual, and our time is don't know. Okay, let's see. First we convert our number in the alphabet, and it's b 1/12 multiply natural log 1 minus 1500 multiply 0.12 over 12 over 75 over natural log 1 over 1 plus 0.12 over 12, and it's b 1 over 12 multiply negative 0.2231435513 over negative 9.950330853 multiply 10 multiply 10 power negative 3, and it's b we get t is 1.87 years. But the question, okay, let me see the question. How many months? Okay, the question 1 month, so we must to convert this to months, and in months 1.87 years multiply 12, and we get 22.44 months. However, he will take 23 months to pay off the debt. Okay, now we explain about amortization schedule. What is amortization schedule? Amortization schedule is a schedule that shows the annual interest expense, the reduction of principal each year, and the ending balance or remaining principal of an amortized loan. Okay, let's see the question first. Okay, the question is, you are borrowing $10,000 for 3 years at an 11% interest rate. Prepare an amortization schedule. Okay, before that, the given is P. P is principal, or we can call present value annuity is $10,000. The rate is 11%, and we convert to point. It's be 0.11. The T is time is 3 years. Okay, for before we do amortization schedule, we must to find the payment first. We use this formula to find the payment. Okay, the formula is present value annuity equal to payment multiply 1 minus 1 over 1 plus r power t over r. Okay, our present value annuity is 10,000, and then we convert the number. We convert number in the alphabet. Okay, the present value annuity is $10,000 equal to PMT multiply 1 minus 1 over 1 plus 0.11 power of 3 over 0.11, and $10,000 equal to PMT multiply 2.443714715. Payment equal PMT equal to 10,000 over 2.443714715, and we get payment for $4,092.13. Okay, this is a amortization schedule based on question in previous slide. Okay, first we put the year based on equation. In question, it said 3 years, so we put year 1, 2, 3, and then we also put annual payment that we find at the previous slide, which is $4,092.13. This annual payment is same amount at each year. And then next we find the interest expense. Okay, interest expense for first year is beginning principal first year, multiply rate given 11%, so $10,000 multiply 0.11, and we get interest expense for first year is 1,100. Next, we find principal reduction for first year. Okay, principal reduction annual payment $4,092.13 minus interest for first year minus interest first year 1,100, and we get principal reduction for first year is $2,992.13. Next, we find uh, remaining principal for first year. Okay, remaining principal, beginning principal first year $10,000 minus principal reduction first year $2,992.13, and we get remaining principal for first year $7,007.87. Okay, next we move to we find the second year. Okay, beginning principal for second year is $7,007.87. We just take remaining principal from first year and we put in beginning principal second year. Annual payment is still same. Okay, interest expense for second year, beginning principal second year $7,007.87 multiply 11%, which is 0.11, and we get interest expense for second year is $770.86, and principal reduction for second year is annual payment $4,092.13 minus interest expense second year, which is $770.86 cents, and we get principal reduction for second year is $3,321.27, and remaining principal remaining principal second year, beginning principal second year $7,007.87 minus principal reduction for second year $3,321.27, and we get remaining principal for second year is $3,686.60. And for third year, beginning principal third year, we just take remaining principal second year and we put in beginning principal third year. The annual payment is still same. Okay, interest expense for third year, beginning principal third year $3,686.60 multiply 11%, which is 0.11, and we get interest expense for third year is $405.53. Principal reduction for third year is annual payment $4,092.13 minus interest third year, which is $405.53, and we get principal reduction for third year, which is $3,686.60, and remaining principal for third year is 0, which is 3,006 beginning principal minus principal reduction for third year.